Hello students, welcome to your first class. Okay, so as you have been studying science since class 1, and in your class 11th you must have studied the subject chemistry, right? And under the subject chemistry you must also have studied the 3 portion of chemistry, that is, you all must be knowing this thing, right? That chemistry is divided into physical, right? Inorganic and organic chemistry, correct? You all must be familiar with this thing, that chemistry is divided into 3 parts, right? Physical, inorganic and organic, correct? In physical chemistry we deal with the mechanism, right? The physical processes that is happening in our day-to-day life. We studied those mechanism, what are the properties applying in our reaction happening. For example, while boiling water, what is the phenomena that is governing the boiling of water, and etc., right? So these are the this comes under physical chemistry. Okay, we study about solid, we study about gaseous, we study about equilibrium, we study about the thermodynamical property. I hope you all have understood all these terms in your 11th properly, and now you are ready to take more, no, I won't say it's more, but a little bit, slight little more complex terms. You are ready to understand those things, okay? So yeah, so chemistry, it has physical chemistry where you will be learning about solid, you will learning about Raoult's law, you will be having gaseous, you will be learning about vapor, you will be learning about colligative property and everything. Cool. Next you have inorganic chemistry. In inorganic chemistry you must have studied S block and the 2 group of the P block, correct? I hope you have studied. And in our inorganic chemistry in class 12 we will be learning about the remaining of the P block elements. We will be learning about the D block element, the F block element, the general configuration. We will be learning about the different methods to different methods to bring up the different metals, non-metals. We will be learning about gold, silver in details, okay? We will be learning about ores, we will be learning about the process governing it. And in our organic chemistry, well, this is the most interesting and slightly tough part than physical and inorganic chemistry, okay? We will be learning about haloalkanes, haloarenes, aldehyde, carboxylic acid, etc. Okay, not to take tension when you learn all these portions separately nicely, and when you read for your exam it will be very much easier. Okay, so today we are going to start with the solid state. Okay, we are going to start with the solid state, the very first chapter of your syllabus. Okay, we are going to start with the solid state. As we know that when we studied states of matter in your class 11th, okay, states of matter, when you have studied all the states of matter in your class 11th, you must have studied about the liquid state, the gaseous state, and now we will study in details the solid state, okay? So let us first see. Okay, now I will read it out and then we will understand the things, okay? We are mostly surrounded by solids and we use them more often than liquid and gases. Obviously, we are more surrounded by solid, right? Like, you know, you are sitting in a solid chair, I'm using a solid pen, you are writing with a solid pen, and everything around you, you will see more of solid. The walls, your room, your ceiling fan, your tube light, everything is more of solid. And liquid, obviously we are breathing gas, okay, we are breathing gases, carbon dioxide, oxygen, you know, we are drinking liquid, okay. So yes, liquid and gaseous are obviously there, but in more we are, you know, surrounded with what? We are surrounded with solids. Correct? You agree with me or you disagree? I hope you are agreeing. Okay, for different application we need solid with widely different properties. Okay, so in different activities we need solid. Like while I am explaining to you, I need this screen, I need this pen. Both of these are solid. This is a small solid, this is a large solid. So solids can be of different size, different shape, different orientation, but ultimately in different shapes and size and orientation we need solid. Okay, understood? Next we have these properties depend upon the nature of constituent particles and the binding force operating between them. Now in your class 9th, in your class 9th and in your class 11th, you must have, you know, understood that we have a matter. Okay, when we have a matter, I hope you know what matter is, correct? So any or thing that has a mass, volume and that occupies a space is a matter. So you must be knowing that this matter has particles inside it, correct? And these particles are in random motion. Okay, so these are the small particles that make up the, what is it making up? That make up the matter. Okay, these are the particles, right? These are the particles. So what is it saying? It is saying that the properties depend upon the nature of the constituent particle, right? Obviously, now how these particles are arranged, how they are behaving, everything of the solid depends on this particular thing, right? Okay, so if the particles are, you know, very far away, or they are arranged randomly, or they are arranged in a particular way, correct? So these things can, what can it do? It can change the overall property of a solid. Okay, so the properties, the solid, basically the solid properties depends upon the nature of constituent particles, and the force operating between them. Now with what force? Now with, as I told you that matter has particles inside it. Now whether these particles are attracting each other or they are in complete opposite direction, or how they are, okay, what are the features, they are in attraction or they are in repulsion, you know, all these factors hugely hamper the property of solid. Done? You have understood the properties depends upon two things, that is the nature of the constituent particles and the binding force operating between them. Understood? Okay, therefore the study of structure of solid is important, right? वैसे तो we have directly one solid, we can just see it in the peripheral and we can comment on it. It is black color, you know, it is long, right? We can just comment seeing the peripheral. Now why do we need to study the inside of the solid, and why do we have a complete big chapter in your 12, that is in your first, you know, in your 12 first chapter? Why is it that we have to study solid state? Obviously there must be something very much important that we need to understand, right? So that is it, that the binding force, how are the particles, you know, how are the particles attracted or repulsed, or they are in repulsion with each other, the details about the nature of constituent particles. When we understand all these things nicely, only then we can completely, you know, comment on solid, and we can develop new feature that will be useful for humankind. Okay. So I hope you know that all these things that we are learning now is really useful for the benefit of human. Different kind of, you know, medicine, different pharmacological, you know, the applications, and lot of things are completely based on chemistry, biology. Okay, so when we understand all these things nicely, we can develop medicines for maybe cancer, we can develop medicines for diabetes, for life killing, COVID, okay, everything is everything you will be able to, you will be able to understand and you will be able to develop when we understand these things in details. Okay, so we need to basically we need to know the binding force between them and the nature of constituent particles in a solid. Correct. The correlation between, now what do we have? The correlation between the structures and properties helps in discovering new solid material. Like I said you, when we understand the basic properly, we will be able to develop numerous new particles that will be useful for the humankind. Correct? So the correlation between structure, what the structure of the solid is and what are the properties of the constituent particle. Are they in random motion? Are they, they are moving to, they are in one direction or they are in random direction. So all these properties, when we understand all these properties and we have proper idea about it, only then we can be, we will be able to discover new solid materials with whatever property we decide. Okay, with our desirable properties like high temperature semiconductors, all these have huge application in today's industry. Okay, companies are making millions and billions of money just by understanding solid properly. Okay, actually scientists are doing that. Okay, I mean the scientists are doing that for a particular company and all these things commercially happens. So we don't need to think about it. So basically we need to know that they are able to develop when we know, what do we know? When we know the structures and properties, when we know the structures and properties of a solid, we will be able to discover new kind of solid where we desire properties like high temperature semiconductors. Okay, we will be able to develop high temperature semiconductor with different magnetic properties, with biodegradable polymers for packaging, etc. Okay, when we do packaging, right, that substance is also a kind of solid. So we can be able to develop new new products that is environment friendly, that is good for the welfare of the human beings. Okay, you are studying solid state, that you are not studying only for yourself. If you understand it in depth, that will be beneficial for the entire human race. Okay, so yeah, these are the things that you need to, what do we need to do? We need to know before we start the chapter. Now when we have the reason why to study, only then we will be able to understand it properly, right? So now what do we have? What are the contents? Correct. What we shall discuss? We shall discuss different possible arrangement of particles resulting in several type of structure. Like I said you that this is a solid. Okay. So here inside the solid there are many particles, right? Many particles club together and form a solid material. Okay, there are many particles. So when we have to discuss the possible arrangement, how will this be arranged? Will it be in this one direction or will it be in diagonally or perpendicular? We have to understand all those things. We have to, when we understand those things, then we will be able to give a comment on which type of structures are we going to produce, which type of solid structure are we going to produce. Okay, the correlation between the nature of interaction within the constituent particles of solid will also be explored. We will also learn about how the nature of interaction, how these particles are are they attracted or are they in repulsion. Okay, we will be able to understand all these things when we go into the depth of the unit. Okay, how these properties get modified due to structural imperfection or by the presence of impurities. Now, like every human being is not perfect, similarly the solid are also not perfect, but we can upscale ourselves and be a better human being. We can be more compassionate, we can be more humble, and that will make, we can be more kind, that will make us a good human being. We can be more up to date so that we get we are along the we are able to compete in the environment that we are living in. Similarly, even the solid also has some imperfection. Now to make those imperfection into perfection, there are lot of things that can be done. Okay, there are impurities which we will be learning in the later portion of the chapter. Okay, now those impurities can be rectified. We can be used, that those impurities can be used for a better cause. Okay, we will learn how we can modify those impurities, how can we modify solid to make it into a more better solid than what it is when we are studying it. Okay, so these are the things that we will be learning in this unit. Now before we start again, now we will go into the chapter. Now before we go into the depth of impurities, and before we go to the packing efficiency, before we go to the different type of unit cells and etc., we need to first understand the thing that we are studying called as the solid state. Okay, we need to have a since your class 9, 10, 11 you have been learning about the solid state, different properties of solid state. But sometimes what happens that we think that these are very easy terms, and we don't need to remember it till the end of the eternity. But what it is actually is, we need to actually remember those terms, what solid states are, what are the basic properties of solid state. Only when you know A, B, C, D, then only you can write A for apple, correct? So similarly, when you know what is solid state, what are the basic properties of solid states, then you will be able to learn some conceptual and tough stuffs that will be helpful. Okay, so let us go into the general characteristics of solid state. Cool? So the first thing is, they have definite mass, volume and shape. I hope you are understanding it when I am dictating it, that there is this solid. Okay, we have a solid. This is our solid. This is our solid. They have a definite mass. They have a definite mass. This pen has a definite mass. It has a definite volume and it has a definite shape. Correct. So this is the thing, that they have definite mass, volume and shape. Now they have intermolecular distances are short. Obviously, what do we mean by intermolecular distances? Like always I have been telling you that there are particles. Okay, there are particles. Okay, now there are lot of particles here. Okay, there are lot of, what are these things? These are the particles. These are the particles. Okay, these particles make up our solid. Okay, these are the particles that is making up our solid. Now, when I say intermolecular distances are short, what do we mean? I mean by this, intermolecular distance means the distance between two particles. The distance between two particles is called as intermolecular distance. Okay, so the intermolecular distances are very short. The intermolecular distances are very short, which means that between these two atoms, okay, between these two particles, there is a very short distance. Since there is a very short distance, hence the particles are clubbed together and we are getting our complete solid structure. Okay, intermolecular distances are very short and intermolecular forces are very strong, which means that when the particles are, the distance between the particles are very less. So what does this mean? This means that the particles are joined together tightly. That means that the intermolecular force is more, correct, which means that the intermolecular force between these particles is too good. Okay, this is the what did I make? I made this is my intermolecular force. Intermolecular force. Understood? Okay, intermolecular forces are strong. Next, what do we have? Their constituent particles, atoms, molecules or ion have fixed position. Obviously, since they are very close to each other, which means that they are in a fixed position, right? Obviously, they are in a fixed position, therefore they are clubbed together and they have intermolecular distances short and intermolecular forces are more. That means that these constituent particles, they have a fixed position, and in their fixed position they are rotating like this. Okay, they are rotating like this. They are rotating about their mean position. Okay, they are oscillating about their mean position. They are incompressible and rigid. Obviously, can you compress this pen? If you try to give lot of pressure, then the pen will break. Correct? We cannot compress it. We cannot compress it and keep it as it is. Okay, so they are incompressible and rigid means it is sometimes, is it easy to move a big stone? Is it easy to move this big stone that carries about 50 kg or 100 kg or 200 or 250 or 500 kg? Is it easy to move it? Is it easy to push it? Obviously no, which means that is what is rigidity. जो नहीं चाहता है अपने जगह से हिलना. Okay, that is our rigidity. Okay, so they are very rigid. That is, it is very difficult to push a huge solid substances. Okay. So these were the general characteristics of our solid state. Okay, this was our general characteristics of solid state. Next, we have classification of solid. Obviously, now we have learned the basic thing of solid state, that is the basic property which you have been studying since eternity. Okay. Now you have classification of crystalline solid. Classification of crystalline solids. Okay. Now what are these? Crystalline solids can be classified on the basis of nature of intermolecular forces operating in them into 4 categories. Now we have crystalline solids. Okay, crystalline solids are crystalline and amorphous solid. We will be learning in the crystalline solids in details. Okay, so crystalline solids can be classified on the basis, like I said, obviously in our solid we have particles, and the intermolecular force plays a very vital role. Okay, so we will learn about the intermolecular force. The crystalline solid can be classified on the basis of nature of intermolecular forces operating in them to 4 categories. We will study into 4 categories the classification, the crystalline solids. Okay, first is the molecular solid, ionic solid, metallic solid and covalent solid. Okay, we will be learning about the molecular solid, we will be learning about the ionic, metallic and covalent. Okay, now let us see the 4 categories. Okay, I have taken this from your textbook. Okay, this is the table that you have in your textbook. We will see the overview, because this table, anything can be asked from here. Okay, anything can be asked from here in the form of MCQ, in the form of 1 mark question, in the form of 2 mark question. So you need to be ready from unexpected portion. Okay, sometimes what happens is that in your examination you learn and go those things which you feel is the most important, but ultimately you get such questions that are very easy and you have never expected them. As a result, your paper goes very bad. So we don't need to do this mistake. We need to be prepared for the best and for the worst. Okay, let's take the worst case scenario. Suppose these are some questions that might not come because there are more important portion in this chapter, but we do never know, right, what type of question can be, there can be different question, and sometimes we get the easier ones that makes the question tough. Okay, so let us get ready for the worst case scenario. Suppose the easy portion comes in your exam. Okay, well, let us see. Like I said, there are molecular solid, okay, ionic solid, metallic solid, covalent or network solid. Okay, now molecular solid, what is the constituent particle? Molecules. Okay, H2O, CO2, these are molecules, right? I hope you know the difference between molecules, atoms and all these things. Okay, these are the very basic thing taught in your class 11th first chapter. Okay, then molecular solids, the constituent particle, this is the solid. Okay, this is the solid that we have. This is the solid we have. Now the constituent particle, the constituent particle of this solid are molecules. For example, we can take any example of a molecule like H2O, then CO2 or anything, okay. We can take H2, HCl, these are the constituent particles of our solid. ठीक है sir. Next, under molecular solid we have non-polar, we have polar and hydrogen bonded. Non-polar means, I hope you know, you have studied class 11 chapter 3 properly, and in that chapter we had something called as electronegativity. Correct? I really hope you know. If you don't know, let me just give a gist, okay. We have two elements, suppose hydrogen and chlorine. Now I think you know that chlorine is more electronegative than hydrogen, correct? Since chlorine is more electronegative than hydrogen, what will chlorine do? Chlorine will will try to take electron density from hydrogen, making it delta negative and making it delta positive. Okay, now since chlorine has taken some electron density of hydrogen, this is called as polar molecule. Okay, this is called as polar molecule. Okay, you understood? Then suppose we took the example of hydrogen. Now in hydrogen and hydrogen, both the molecule, what is it? In both the in this hydrogen and this hydrogen, none of them are more electronegative, okay, or less electronegative. As a result, no electron, there is no shift in electron density. So they are not polar molecule, and hence they are non-polar. Okay. I hope you understood this thing. Okay, this is the thing, that is polar and non-polar. Now you may ask, ma'am, what is hydrogen bond then? Okay, hydrogen bond means, suppose we have this thing. Okay, we have this oxygen, we have hydrogen, this is the thing. You will get these things in details in your later chapter. There is some interaction between this hydrogen and this oxygen. Okay, there is some interaction, and this interaction is called as hydrogen bonding. Okay, this interaction is called as hydrogen bonding. What it is, how it is happening, this is we will study in details in the later part of your syllabus. Okay, or I think you must have studied it in your class 11. If you have studied it in your class 11, you must know this nicely. Okay, so these were the things that this is non-polar, polar and hydrogen bonded. Cool. Now the bonding attractive forces, like I said you, there is, we understood what the constituent particle is. Now there is some forces, attraction forces or repulsive forces. What are those forces? Okay, again these are the terms that you have learned in your class 11. Like I always say, everything is linked, everything is, you have to clear all the terms, so that in your higher classes, when you get all the term back, that is easier to recall. Okay, like if you have studied electronegativity nicely, hydrogen bonding nicely, it must be very easy to catch what I am saying. Okay, here the attractive forces are dispersion or London force. Okay, dispersion or London force, I hope you know. So these are the forces acting here. Next we have dipole-dipole interaction, and last one we have hydrogen bonding. In polar we have London force, in non-polar we have London force, in non-polar we have London force, in polar we have dipole-dipole, and in hydrogen bonding we have hydrogen bonding interaction. Now examples. What are the examples? Examples are ArCCl4 is, then we have H2 and I2 are non-polar, CO2 polar, HCl polar, SO2. Okay, these are example of polar and non-polar. Hydrogen bonded is H2 is hydrogen bonded example. Now the physical state. Now we know when we have something, we can see the physical state. Like this solid is, what is it? It is hard, correct? So we can see the physical state. Okay, the physical state of first is solid. The non-polar are solid, soft. polar are soft, but the hydrogen bonded ones are hard. Okay, next we have 3 of them are insulator. Insulator means no electricity can be conducted. Okay, no electricity can be conducted. And the melting point, I hope you know melting point, you have studied it in class 9. The point when the solid change to liquid. Okay, the melting point of non-polar is very low. For polar and hydrogen, the melting point is low, but not not less than non-polar. I hope you understood. Okay, I hope I made my point clear for the molecular solid. Next we have ionic solid. Okay, in ionic solid again we have another solid state here. Here the constituent particles are ion. Okay, this constituent particles making this molecule is ion. We have different ions, so those are the things. Now you know, right, what is ions? Ion means one will lack electron, and the other one will have extra electron, and one will give to the other and make a molecule like this. Okay, so the constituent particles is ion. The this is one particle, other particle, in between them the force of attraction is Coulombic or electrostatic force of attraction is there. This is again you have studied in your physics in class 9. Okay, or in class 11. The examples are NaCl, MgO, ZnS, CaF2. These are the examples of ionic solids. Okay, next we have the physical nature. They are hard and brittle, which means that they are very hard and brittle. Okay, this is the physical state of ionic solid. Now electrical conductivity, do they conduct electricity or not? In insulators in solid state, but conductors in molten state. Now ionic solids are insulator. In solid state ionic solid cannot conduct electricity, but in molten state, okay, they can conduct electricity. Okay, their melting point is very high. Which means you need to give more heat to melt it into solid to liquid. Next we have metallic solid. Now in metallic solid again the constituent particle like this, they are positive ions. Okay, they are positive ions in a sea of delocalized electron. Okay, we will learn about it in detail. There is Frankel, okay, Frankel and the positive. There is a box where we will have the sea of electron. Okay, let me just explain it to you here itself. We have a solid here. Okay, there is lot of electron. Okay, there is lot of electron, and this is called as the sea of electron. Okay, these electrons are too many. In them we have some positive. Okay, those are metallic solid. Here we have metallic bonding. Example iron, copper, silver, magnesium. Okay, and the property is they are hard, but they are malleable. When we malleable means you understand it, like clay. Okay, they are malleable and ductile. Okay, we can change the shape of iron, copper, all these things. Okay, they are conductor. They are conductor, which means that like iron conduct electricity. Okay, so they conduct electricity. Their melting point is high. Next we have covalent or network solid. Here the constituent particles are atom. Okay, we have atoms as our constituent particles. Here covalent bonding is there, and examples is SiO2, quartz, right? Quartz watch, that things. Okay, diamond is under diamond is also a solid that comes under covalent or network solid. They are hard and they are also soft. Okay, like graphite is soft, right? Pencil nib, they are soft. They are conductor. Okay, SiO2, quartz and all are insulator, but there is an exception that the graphite they conduct electricity. Okay, and their melting point is very high. Now with this we will end this class. See you next class.